Hello, and welcome. The following tutorial will talk about pairs and triplets charts. These are the main tools for visualizing spatial model data. Once you are done with this tutorial, you will recognize the different charts available in the spatial model. How to produce each one of them and what is the information delivered by each chart type. The spatial model charts can be accessed from the spatial model's main screen by clicking on the button located fifth from the left. Please note that if you are focused on the first tab, the Pairs tab, clicking on the Chart button will lead you to Pairs Charts screen. While if you are focused on the second tab, the Triplets tab, clicking on the Charts button will lead you to the Triplets charts. Let's start with the Pairs charts. Once you click on the Chart button and focus on the Pairs chart screen is shown. On top of the screen are located several read-only fields, with the pairs metadata. These fields include the link ID and description, the target station of the pair, the measurement and the units. The default time frame displayed is the last week where the current date is the end date, and several days ago is the start date. On the right top side of the screen is a drop-down field, which enables switching between the chart type. On the right side of the screen are located 4 tabs with several fields each. These tabs and fields will be used with various types of charts. A proper explanation will be given to each one of them. On the bottom of the screen, the information field is located. This field is used for displaying dynamic information. For example, when records are loaded from the database to the chart area, this field contains information about this process's progress. The Pairs chart window contains 5 types of charts. The first one, which will be displayed automatically when the screen is loaded, is the Spatial Limits chart. This chart displays a line chart which contains the actual and predicted values of the chart, in focus the lower limit for the predicted value, and the upper limit for the predicted value. The horizontal axis displays the dates to which the chart is related. Note that you can change the scope dates by editing the dates directly or by clicking on the right and left arrows. On the right side of the screen on the first tab is located checkbox named Force Y Scale. This field, combined with the min and max value, enables us to scale the y-axis chart. If you do not select the Force Y option, the chart will be scaled automatically based on the chart data. The Show User Limits and Show Stat Limits fields enable to display a horizontal line related to these values. Note that after each change in the chart setup, it is needed to refresh the chart using the most upper left located button. The last button that needed an explanation is the Camera button located on the 4th place on the left side. This button enables us to capture a screenshot from the current chart. The second chart is the Actual versus Predicted chart. This chart can be displayed using the second option on the drop-down field of chart type located at the upper right corner of the screen. The Actual versus Predicted displays a scatter chart. Each point in this chart type has 2 coordinates. The horizontal axis is the actual value, and the vertical coordinates are the predicted value. A situation of a perfect model where the actual results equal to the predicted results with all points located on a diagonal line with a slope of 45 degrees. This 45-degree line can be displayed by checking the field titled Display 45-degree line. This actual versus predicted chart can be used for several diagnostics. For example, if most of the points are located above the 45-degree line, it means that the model repeatedly deviated by predicting values higher than the actual values. Or, if most of the points are located below the 45-degree line, it means that the model constantly deviated by predicting values lower than the actual values. The third chart type is a histogram. This histogram shows the deviation between the actual and the predicted value. Similarly, the horizontal axis shows deviation both in percentages and physical values. The vertical axis shows the frequency in rates. If the prediction model is accurate, the histogram should concentrate on the center. The wider and lower is the histogram. It is a sign that the model is not accurate. Once again, please note that you can change the scope of the dates from the fields on the upper side of the screen. And refresh the chart using the refresh button located on the left side of the screen. The next chart, which is the force from the drop-down field located on the upper right side of the screen, is a chart that describes the frequency and lengths of violation of particular limits. Each time the measurement instrument's actual value crosses the upper or the lower limits prediction, the spatial model engine starts to count time for this violation. As long as this violation exists, the counting process continues. The counting only stops when the measured instrument's value goes back to be between the high and the low spatial limits. The current chart shows the frequency and lengths of this violation. For example, you can see that the violation of 15 minutes occurred 4 times. However, the current chart also enables some additional features. On the right side of the screen located a checkbox titles force limits. Below this checkbox is located 2 fields, a spatial image change and the other is a delay time. Using these fields, you can simulate what will happen to the histogram if the limits and the delay time would be forced to be as requested. The 5th chart shows an additional scatter chart, a combination of 2 data sources. This shot shows the adjusted source versus target data. The term adjusted refers to the fact that the source station's data is adjusted by time according to the flawed time. This means that each point in the scatter chart shows the actual measuring and the measuring of the same drop of water some minutes ago at the source station according to the flow time. Note that as in the previous scatter chart, you can scale the chart's minimum and maximum value. It is also possible to show the 45-degree line using the checkbox on the screen's right side. The last chart is the triplet charts. The triplets are a set of 2 pearls with the common station. The triplets produce the value that reflects how normal the combination of the 2 pairs. Full details about this algorithm, please go to the tutorial about triplets. The current chart shows 3 lines. The red line is the critical value, the value from which an alarm should be triggered. The blue and the green lines are the actual triplet value. When the blue line crosses the red line to the upper side of the chart for a moderate amount of time, the average of their value defines when the triplet should trigger an alarm. The alarm of the triplets is used for verification of the pair's alarms. Thank you, we hope this tutorial was helpful and clear. For more details, please go to our website.